All right. Diffraction by a double slit. All right, so here's the thing. If we're talking about single slit interference patterns, it probably hasn't escaped everyone's notice that a single slit and a double slit maybe have some overlapping ideas, because if I had two slits letting lasers through, isn't that just two single slits? Oh, man. So it turns out the double slit diffraction pattern gets superimposed on the much broader single diffraction pattern. And what that means is that when we have a two-slit interference pattern, yeah, you get a whole bunch of equally spaced stripes. Isn't that what we talked about? Equally spaced stripes. And yet, what we didn't pay attention to was a little ways out, it dies out. But it actually dies out in the same pattern and then comes back again in the same pattern as a single slit interference pattern. It's actually a superposition of the two functions. And so this is a great example of like a function envelope where the single slit interference function envelope gets superimposed on top of the admittedly more intense double slit envelope. And so the intensity kind of attenuates out and then comes back again and then dips out again, where the predicted destructive interference would happen for the associated single slits. Make sense? Single slit gets stacked on top of double slit, okay? So I'm going to label this up. These stripes are the double slit pattern. Whereas the envelope, maybe I'll make it pink. The envelope represents the single slit pattern. Of interference. All right, so the bright constructive maxima, and here I am trying to use my vocabulary words, are caused by double slit interference pattern, but the intensity still falls to zero where the minima are predicted from the single slit. Oh, and just so that I'm highlighting vocab, minima, again, are the dark, and I'll be redundant, dark nodal lines. So the brightness of each bright fringe due to the double slit pattern is going to be modulated. Again, I'm using my vocabulary, but I want to make sure that we've used it properly, by the intensity envelope of the single slit pattern. Okay, so one's going to be modulated by the other. If you're somebody who's into calculus and function notation, we're thinking of this kind of like, hey, if it was like f of x was the function for single slit interference and g of x was the function for double slit interference, then the result would be f of x plus g of x. Does that sit well with everybody? That's the idea of superposition of functions, though. Okay. And I've been saying this kind of as we've been going through. Why would I care about this? Because this was something that I think never got presented to me when I was in high school, was why would I even want to investigate this? Besides just wanting to know about how the universe works, why would this be valuable? And really, material sciences. Really, we want to be able to investigate all the little holes and cracks in the stuff around us. And it doesn't have to just be material sciences. I think there's a picture of a dragonfly head here. We could check to see what the surface imperfections are, or the cracks in the insect's exoskeleton are, or what have you. It doesn't have to be cracks, though. It could be pore size. So maybe there's some sort of a pore that exists in a natural thing, like an insect's head. And we'd like to know how big are the holes in the bug's head. We could use something like this to investigate that. It's a great measurement tool. So radiation shining through a hole turns out to be a really good way to measure how big is the hole. That's neat. Okay.